Welcome to the High Voltage AI Podcast. I'm Alex Reed.
And I'm Emma Quinn.
Welcome to the Deep Dive. We're here to unpack some really crucial topics for electric utility engineers.
That's right. And this is actually part of a special week-long series we're doing with the PXRD newsletter on Substack.
Yep, all week we're digging into overhead and underground construction, why we use what we use, the pros and cons, all that good stuff.
And today, Monday, we're kicking things off with something, well, genuinely transformative for transmission design. FERC Order 1920.
Specifically, we're zeroing in on how these new 20-year planning horizons are really revolutionizing the field.
It's a big deal.
It really is. People are calling this the biggest shift in transmission planning since deregulation way back when, not just another update.
Definitely not.
So today, we'll unpack what the order actually requires, why it matters so much for you, the engineer, and how it's fundamentally reshaping long-term infrastructure design.
We'll look at the new ways to evaluate benefits, the mandatory look at grid-enhancing technologies, and a total overhaul of cost allocation. It's pretty comprehensive.
So what does it really mean to be designing for, 2045 today? Let's dive in. Okay. Let's unpack this FERC Order 1920. The source material, right off the bat, calls it the biggest change to transmission planning since deregulation. It's a huge statement.
Yeah.
And it just took effect June 2024.
Yeah, and what really struck me was the challenge MISO planners face, their first 20-year regional plan under this order. I mean, how do you even start designing for load growth you can't possibly predict 2 decades out?
It sounds almost impossible, planning for data centers that aren't even concepts yet, or energy needs from tech we haven't invented.
Exactly. And their solution, get this, required abandoning 50 years of traditional planning approaches.
50 years, wow.
Yeah, and embracing these scenario-based methodologies, stuff that honestly would have been seen as like engineering heresy just 5 years ago.
That's a massive pivot. So what came out of it?
A $30 billion transmission expansion plan. Billion with a B.
Whoa.
And it's designed specifically to handle that uncertain future growth.
Yeah.
More data centers, tons of renewables coming online, electrification, maybe economic development.
Yeah.
We can only guess at now. It's building for theoreticals.
Okay, so that really shows the scale. But what exactly did FERC Order 1920 change? What are the key mandates?
Right. So before, planning was maybe 10, 15 years out, often reactive, incremental. Now FERC says, nope, you need a 20-year planning horizon for long-term regional stuff. That's mandatory.
20 years, okay.
Then there's enhanced benefit evaluation. Projects have to show value across 7 specific categories. We'll get into those.
7 categories, got it.
Also, grid-enhancing technology integration. You have to consider GETs, the smart stuff, before you jump to building big new lines.
Optimize first.
Exactly. And then there's cost allocation reform, completely new ways to figure out who pays. Plus, better stakeholder processes, more transparency.
So, for an engineer listening right now, what's the day-to-day impact? This sounds like more than just checking boxes for compliance.
Oh, absolutely. It's a total rethink of how transmission systems evolve.
Yeah.
You, the engineer, now have to design for uncertainty, plan for multiple futures at once.
Not just one straight line forecast anymore.
Right. And you have to justify these big investments based on this whole portfolio of benefits. Not just, does this one project pencil out? It's moving from reactive, single project thinking to proactive, system-wide, future-focused design.
Okay. Let's talk about those 7 benefits. You said every project has to demonstrate value across these. That sounds like a big shift in how you justify a project.
It really is. It forces you to think multidimensionally about impact. Let's touch on a few key ones. First, reliability benefits.
Okay.
We're moving past just the basic N-1 contingency plan, planning for one thing failing.
Right, the standard approach.
Yeah. Now it's about probabilistic assessments. More sophisticated modeling, risk-based design. What's the actual probability of losing X megawatts of load? What's that cost? And this includes deeper analysis for data centers where even a blip is hugely expensive.
Makes sense. What's another big one?
Adjusted production cost benefits. This isn't just simple cost modeling anymore. It's full-on economic dispatch simulation across multiple future scenarios.
So bringing market modeling right into transmission planning.
Exactly. How do renewables integrate best? How do you optimize storage, like batteries? Market efficiency, fuel diversity, it all plays in.
Okay. And you mentioned extreme weather earlier.
Yes, extreme weather and natural disaster recovery. This isn't just about standard design criteria anymore. It's explicit climate resilience planning.
So baking climate change into the design.
Pretty much. Enhanced design standards, more redundancy, using detailed climate data, building things to actually withstand wildfires, heat waves, whatever the future throws at us.
I can definitely see how looking at those benefits changes the whole scope. And you said these feed into the scenario-based planning requirement.
Precisely. Because with a 20-year horizon, a single forecast is, well, useless, basically. The grid's way too dynamic.
Too many unknowns.
Right. So the required analyses now cover multiple futures. You'll have your base case kind of business as usual, then a high load growth scenario, maybe lots of EVs and heat pumps, a high renewable scenario, and those extreme weather scenarios we just talked about.
So you're stress testing designs against several possible futures.
You got it. And that means using more advanced methods. Stochastic analysis, using probability, real options analysis, valuing flexibility. The goal is robust planning, finding solutions that work reasonably well no matter which future actually unfolds.
Can you give an example, maybe with those data centers you mentioned?
Sure. For data center integration, you can't just plan for one growth rate. You need scenarios. Maybe a conservative one based on current trends, a moderate one with more AI and cloud growth, but then maybe an aggressive one, hyperscale campuses popping up, demanding gigawatts. Each scenario needs a different transmission solution, right?
Yeah.
Maybe just substation upgrades for the conservative case, but entirely new high-voltage lines or grid architectures for the aggressive one. You're designing for that whole range.
Designing for multiple futures at once. That's complex.
It is.
Now, something else you mentioned was the mandate to consider grid-enhancing technologies, GETs, before building new lines. That sounds like a really practical shift.
It's a huge shift. It's about optimizing the heck out of the existing system first.
Squeezing more out of what we have.
Exactly. Take dynamic line ratings, DLR, instead of fixed conservative ratings for power lines based on worst-case weather.
Which we know often isn't the reality.
Right. DLR uses real-time weather data, wind speed, temperature, to tell you exactly how much power that line can safely carry right now.
And that gives you more capacity.
Typically 15 to 30% more capacity, often with minimal new hardware. It's like dynamic speed limits based on actual road conditions, just smarter.
15 to 30% is a lot. What else falls under GETs?
Advanced power flow control. Using power electronics to actively push or pull power where you need it. Think of things like TCSCs or smart wires. They act like intelligent valves or traffic cops for electricity.
So redirecting power to avoid congestion without building a whole new highway.
That's the idea. Better use of the grid we've already paid for. There's also transmission switching, optimizing the grid topology in real time. Small changes can unlock 5–15% more capacity sometimes.
Thinking smarter, not just bigger. Okay, this is really interesting. And then there's the money side, the cost allocation revolution. How does that change things?
This is fundamental. In the past, costs were often assigned directly to whoever requested the project.
Yeah, the causer pays model, often, which could sometimes kill projects that had wider benefits.
Exactly. It created roadblocks. The new framework under Order 1920 introduces regional cost sharing. Costs get allocated based on who actually benefits, distributed across a wider region.
So if a project helps multiple states, they share the cost based on their share of the benefits.
That's the principle. It shifts the focus from purely local needs or burdens to optimizing the region. It encourages collaboration.
And that opens the door for what you called multi-value projects.
Yes. This is a key opportunity for engineers. You can now design projects that deliberately hit multiple benefit categories.
Because the cost gets shared more broadly if the benefits are broader.
You've got it. So say a line primarily needed for renewables. If you design it smartly, it might also boost reliability in another area, reduce overall system losses, and increase market competition.
And the cost for that single line gets spread across all those beneficiaries.
Right. Based on the quantified value of each benefit, it completely changes the economics and justification for building needed infrastructure.
Okay, so the whole planning process looks different now.
Totally different. We're moving away from those shorter 3 to 5 year project-specific cycles towards continuous rolling 20-year planning. Regular updates, comprehensive benefit-cost analysis across that whole long horizon. For all potential projects, it's much more dynamic, more iterative.
So what does that workflow look like for an engineer now?
Well, the sources sketch it out. It starts with scenario development, really building out those multiple 20-year futures. Then a portfolio-wide needs assessment across all the scenarios.
Finding the common needs or the biggest risks.
Kind of, yeah. Then solution identification, where you explicitly compare traditional wires with those GET alternatives. Then the hard part, benefit quantification across all 7 categories.
That sounds like it needs new tools.
Definitely. Then you apply the new cost allocation methodology, and finally, there's more robust stakeholder review all along the way. It demands new tools, stochastic planning software, advanced market simulation tools, climate analysis integration.
So the big question for engineers listening, what does this mean for my career?
It's a huge opportunity, honestly, but it requires adapting. FERC 1920 is creating new specializations.
Like what?
Well, think about scenario planning specialists, people who just focus on building and analyzing those futures. Or benefit quantification analysts, GET integration engineers, experts in deploying those technologies, regional planning coordinators. These are becoming distinct roles.
And it demands new skills too, right?
Absolutely. Enhanced skill requirements. You'll need to be comfortable with stochastic analysis, probability, understand market modeling, electricity economics, climate science basics, and definitely better stakeholder management communication skills.
So continuous learning is key.
For sure. It opens up tons of professional development opportunities in advanced planning methods, tech integration, economics, regulatory affairs. It's really a call to upskill.
Are we seeing examples of this already paying off?
Yeah, definitely. Look at MISO's multi-value project portfolio, that $30 billion plan we mentioned.
Right.
It's designed for renewables, reliability, efficiency. And by taking that portfolio approach with regional cost sharing, they estimate a 40% reduction in development costs compared to piecemeal planning. 40%.
That's incredible.
Or look at SPP, the Southwest Power Pool. Their integrated transmission planning has invested about $8 billion, achieving a 2.5 to 1 benefit cost ratio. That's huge value, driven by combining renewables, reliability, and using GETs.
Wow. So the benefits are tangible.
And California ISO is investing heavily, like $15 billion in resilient transmission, explicitly integrating climate science to handle wildfire risks and extreme weather. It's happening now.
Okay, so pulling it all together. The bottom line for transmission engineers.
The bottom line is FERC Order 1920 isn't just another regulation. It's truly revolutionizing how we plan and build the grid. This shift from reactive project-by-project thinking to proactive portfolio-based long-term planning. It's challenging, yes, but it's also full of opportunity.
So embrace the 20-year horizon, plan for uncertainty with scenarios, quantify those broad benefits, don't just look at single project costs,
Right.
and make GET standard practice, optimize first.
Exactly. And add enhanced regional coordination, more sophisticated economic analysis. It really does reshape career paths. It demands new skills, new ways of thinking.
We've covered a lot today on the planning framework under Order 1920. Tomorrow, we're going to shift gears a bit within our PXRD newsletter series and look at a key technology enabling this future, grid-forming inverters.
Right. How they provide things like synthetic inertia, voltage control, crucial for grids with lots of renewables. We'll explore what that means for protection and control engineers.
Then later this week, we'll circle back Wednesday on the implications of 20-year horizons, Thursday a deeper dive on GETs, and Friday specifically on the career impacts of Order 1920.
So a lot more to cover. But for today, maybe a final thought to leave folks with. As engineers, we've always focused on the how to build it reliably, efficiently. But with Order 1920 pushing us to plan 20 years out and define broad societal benefits, are we now also becoming the architects of the why? Are we shaping the future energy landscape itself, not just responding to it?
That's a great question to ponder. Okay, that wraps up today's deep dive. We really hope you found this insightful.
Yeah, hopefully useful. If you have feedback or questions, please do reach out. You can email Alex at alex.read.power.podcast@gmail.com.
And you can reach Emma at emma.quinn.power.podcast@gmail.com. We'd love to hear from you.
Please do.
Join us tomorrow for more from the PXRD Newsletter's weekly series.
Thanks for listening.